Hello there. So we're ready to start doing some machine learning programming in Python. I thought it'd be good before we did that to just do a little bit of an introduction to machine learning. So this will be brief, but I think important as we start talking about how we can use Python to do machine learning. So I'm sure you're excited about machine learning. I'm sure that's one reason you're watching the videos, is to learn more about it. And there's a lot of hype out there about machine learning, about how we see in science fiction movies, for example, ways that machine learning kind of takes over the world. And you're using machine learning every day. No matter kind of where you're at or what you're doing, there's machine learning somewhere in that process. You may be familiar with Alexa or Siri or tools like that. That's got machine learning built into it. Self-driving cars, we hear a lot about, the Tesla and others that are out there. And then, of course, like I said, we kind of get scared by the Terminator and Skynet and it all taking over the world. Well, that's not going to happen, and you'll soon realize why as you learn more about machine learning. So basically, what is it? So essentially what we're doing is we are giving to machine learning algorithms representative data that represent a certain problem that we want solved, and then the algorithm can produce a solution for us, as opposed to programmers creating the solution. So we'll talk a little bit about the difference between software development projects and machine learning projects. But a simple example of a machine learning application is spam filtering. So spam is defined as email that you don't want to get. And what you'll notice is that you probably still get some spam, but compared to what it was like a few years ago, you don't get hardly any. And the reason for that is because machine learning algorithms have been developed that email programs and email services use to stop spam from arriving in your inbox. And we could have written a program to do that, but each time new types of spam came out, we would have to modify our program. In a machine learning solution, we simply show the machine representative samples of spam and not spam, and it, quote unquote, learns the differences between those. Now, learn, when we say machine learning and we say learn, it tends to denote a human type of learning activity. This is using a computer, and it's simulating in many ways how humans learn, but it's not exactly the same thing. But the point is you can give it representative data for a particular problem, and it can solve it. So the key is having that representative data, and we'll talk more about that in just a minute. There's basically three types of machine learning. We have supervised learning, where we train the machine with representative data, which is what I've been talking about, and that's where we're going to start our learning journey, is with supervised learning. It's probably the most popular application of machine learning today. Unsupervised learning, we basically just give the data to the machine and it figures out potential solutions. This has some promise and it works well in certain situations, but it doesn't work for all. The reason there's three kinds of things here is because there's different types of problems that we have, and these each would be used in those particular problem sets. Reinforcement learning is really interesting. You can think of a machine retraining based on targets and results. So you can think of an algorithm that's seeking to find its way through a maze, for example, and then based on either finding its way or running into walls, it can retrain itself. And that's really exciting today. We see more and more of that type of reinforcement learning happening. So let's talk about a typical software development workflow. We start with defining requirements or creating requirements. We define a problem. Then we design a solution to solve that problem, and then we implement it in code. And then we test the solution against the requirements that were given us. And then if the tests pass, we go ahead and deploy it to solve the problem. And of course, anywhere along here, we could go back to the previous step or steps. If, for example, we get into testing or implementation and we find that we need to redesign or get more clarification on requirements, we do that. And this is also a very iterative approach. So typically in software development, we're iterating quickly. So the problem the problem defined may start as a small part of a larger problem, and we keep iterating until we solve the larger problem. So that's basically that's a typical software development workflow. So let's talk about a typical machine learning development workflow using supervised learning. We define an objective that we want. You can think of it like a solution, but you'll hear people in machine learning talk more about it as an objective, a goal, or a hypothesis that we want to prove. We gather representative data. Remember, in supervised learning, we need to gather representative data that will help solve the problem. And we often have to prepare or work with that data to get it in a form that the machine can use. And then we select and train a machine learning model. We then evaluate that model's performance. And at that point, we may go back and gather more data if the model performance isn't as well as we want it to be. And when I say model performance, what I'm talking about is does it look like it's solving the problem? Does it look like it will solve the problem? And sometimes you have to go all the way back and start over again with a new hypothesis. Anyway, if that looks good, we go ahead and deploy the model into production, and we just monitor the model performance. But just like in software development, we're usually solving larger and larger problems or more diverse problems, and we can basically go back around the whole series of steps again. So that's a basic view of how supervised machine learning works. And we're going to go through all these steps, and you're going to see how to do all of this in Python. So that's coming next. And we're going to start that with something called the Iris Dataset. So if you go out on Wikipedia and search for the Iris Dataset, you will find a dataset with 150 rows in it. I've only pulled up the first 15 here. And there are 3 different types of iris flowers that this dataset represents. And based on the sepal length and width, the petal length and width, we will be able to determine the species of flower of these 3. So this is a very famous data set that's used in machine learning. We kind of consider it like a Hello World application, and that's where we're going to start. Now, in order to do this, we're going to have to get familiar with how we work with data, because remember, gathering representative data preparation is necessary before we start selecting and training a model. So that's why I wanted to give you some exposure to this data, and then we are going to jump right in, and we're going to have to learn some things in Python about data, how you load it, how you manipulate it, how you work with it before we actually go through and complete the Iris dataset. But again, the idea will be that we will train a model using this data, and then for any combination of sepal and petal length and width, we'll be able to feed values in and have it tell us which of these 3 flowers it is likely to be. And you can learn more about that data set if you will go over to Wikipedia and search for the Iris flower data set. You can start reading about this before we get into this next time. I'm not going to spend a whole lot of time going through the details of the background of the data set, but you can see that these are the flowers. And the whole data set is here. If you actually hit show, you can see all 150 rows are here. And you can see the 3 different species of flower that we're dealing with. And you'll notice that we do a lot of looking at the data here. Here's a scatter plot. You can learn about what scatter plots are. So you can see they're doing a lot of work with the data. This is a simple machine learning problem. So it's typical that 90% of your time in any machine learning problem is spent working with data. So if you're kind of don't like working with data a whole lot, you're going to probably not like working with machine learning too much, because for the most part, it's all about the data. And so that's what we'll be focusing on. And so please take a look at this, and we will jump right in with looking at Python and specifically list arrays and some of the other data structures that are out there that we need to work with the data.